Hello students, my name is Manoj Verma and on this channel I will be discussing the topics, the chapters and the past paper questions from the previous years, and I will be focusing on the AS and the A level of chemistry. So my today's topic is the mole concept, and I will be solving a few of the questions taken from the mole concept chapter. So I think you are ready to concentrate on my video, and let's start. So the first question says that it's a multiple choice question. So which compound contains 2.35 into 10 raised to 20 molecules in 2.50 gram? The Avogadro constant is given 6.02 into 10 raised to 23 per mole. The MR values are given: carbon monoxide 28, carbon dioxide 44, sulfur dioxide 64.1, and sulfur trioxide 80.1. So what is the answer? So let's again go back to the question. It says that which compound contains so many molecules. Now one method could be that we find out the number of moles represented by these many molecules. So for doing that, what we can do is that since we know that one mole contains 6.02 into 10 to the power 23 molecules, so we need to know that how many moles will be there in 2.35 into 10 raised to 22. So from this you can uh, go to the conclusion that the number of moles, that is this, will be equal to 2.35 into 10 raised to 22 divided by 6.02 into 10 raised to 23. On solving this, you get 0.039 moles. That means these many number of particles represent 0.039 moles. Now our next approach would be that if we have 2.5 gram of each of these compounds, carbon monoxide, so on, which of them would be 0.039 moles? So that should give us the answer. So I have tried the third option, that is 2.5, that is the mass, and sulfur dioxide is 64.1. So I divide this 2.50 by 64.1 and I get exactly the same value, 0.039 moles. So obviously this should be the answer. C should be the answer. So if you divide 2.50 by the other molar masses, like if you divide by 28 or 44 or 80.1, in none of the cases you will get the answer as 0.039, which clearly indicates that C is the correct answer for this question. Hope you followed this. So now let's go on to the next question, and the next question says that what is the concentration of hydroxide ions in a solution containing 5 gram of barium hydroxide in 250 centimeter cube, and the MR of barium hydroxide is 171.3. Now you have to first notice that all these values are in the units of dm cube, right? Whereas this is centimeter cube. So you have to convert the centimeter cube to dm cube, right? And so it's mole per dm cube. So a dm cube is 1000 centimeter cube. A dm cube is 1000 centimeter cube. So if in 250 centimeter cube we have 5 gram, so how many grams we will have in 1000 centimeter cube, that is in 1 dn cube. So the answer is 20. So this is the same thing as 20 grams of barium hydroxide in 1 dn cube or per dn cube. So it's 20. Now we find out the number of moles by dividing this 20 by its molar mass, 171.3. So we get the number of moles of barium hydroxide as 0.1167. But that's the number of moles of barium hydroxide. But don't forget that in 1 mole of barium hydroxide, there are 2 moles of hydroxide ions. So the number of moles which you get over here should be multiplied by 2 to get the number of hydroxide ions, which we do over here. So we get 0.2335 mole per dn cube, and which compares with the answer D, and therefore D is the correct answer. I hope you understood this. Please go through once again. If you have not understood, please go through the solution once again until you are convinced. We go to the next question, and the next question says that a sample of 15 gram of vanadium reacted completely with 7.07 gram of oxygen. What is the formula of the oxide? And the AR values of vanadium is 50.9, oxygen is 16, and we have to find out the formula. So first step would be to find out the number of moles. So 15 divided by 50.9 would be the number of moles of vanadium, and 7.07 divided by 16 will be the number of moles of oxygen. So you get the ratio of the moles as 0.295 is to 0.442. Now if you divide both these values by 0.295, that means this value as well as this value is divided by 0.295. So this part becomes 1 and this part becomes 1.5, which is not a whole number ratio. So again multiply both the numbers by 2. So this becomes 2 and this becomes 3. So this is a whole number ratio, V2O3. So this is the correct answer, V2O3. Hope you understood this. If you have not understood, please go through the solution once again. Alright, we go on to the next question, which is quite straightforward. What is the pressure when 5.00 mole of nitrogen in a container with a volume of 150 meter cube is heated to 500 K? So the formula is given, PV is equal to nRT, the value of R, the gas constant is given, and you have to find out the pressure. So pressure is equal to nRT upon V, and we simply have to substitute the values. N is 5 mole, R is 8.31, and the temperature is 500 K divided by the volume, which is 1.50 meter cube. Remember that in this question, PV is equal to nRT, the volume has to be in meter cube and not in decimeter cube or centimeter cube. So this is the key point that you have to remember, that it should be in meter cube, because here we are using the SI units, joules, and along with the SI units, the unit of length and volume is meter cube in SI units. So you have to use this. On solving this, you get 13850, but the answer should be up to 3 significant figures, because you have not more than 3 significant figures in these values. So this answer should be converted to 3SF, which is 13900, and therefore this is the correct answer, the C. So I think you understood how to solve these 4 questions based on the mole concept, and keep practicing, because in mole concept there are varieties of problems and students often find it difficult to apply the correct formula in the correct way, correct context, and therefore we need to practice more number of questions. Thanks a lot for watching. If you like the video, please give it a like and comment and share. Thanks a lot.